Hello, I'm Graham Lewis, and in this short video we're going to discuss what the standard deviation is, what the variance is, and how to calculate this both by hand and by using Excel. So first let's start with a population of a class test results. So here we have a class result, and first thing I want to do is work out the mean. So to work out the mean in Excel, just to remind you quickly, what you have to do is hit equals to get the formula bar showing, write average AEV, and I'll choose the average there, select the cells I want, which is, you can see there, C4 to C18, close the bracket, hit enter, and you can see that my mean is 78.6. Now the standard deviation uses the mean, so we can only use the mean if the mean is a good measurement of central tendency. And if you remember, that means we have to have no outliers. So let's check in Excel and draw the box plot to see if we've got outliers. So if you remember, to draw a box plot in Excel, highlight the data, only the data, not the title. Go to Insert, and then I'll just move myself down here. Remember, it's this little badger here you want to click on, and then insert statistic chart and choose box and whisker diagram, and then let's have a look at this box and whisker. So you can see here is the box and whisker for the 15 students in this class with their marks, and you can see there are no outliers, so no crosses at the ends here. So there are no outliers, which means that the mean is a good measurement to use. It's the most mathematical because it takes into account the size of every number, so we don't need to use the median. We can use the mean, and it is the best one to use. So once you've decided that the mean is an appropriate measure, you can then use the standard deviation, which measures the distance from the mean. So what I'm going to do is take the actual mark, which I'll call all of these marks x's, and I'm going to subtract the mean, which I'll call mu. And in this case, that's equal to x minus 78.6, because the mean is 78.6. So I'll take this 58 and minus 78.6, and I get an answer off. I'll write that down in a minute. And I'm going to pick a number bigger than 78.6 here, 84 minus 78.6, and I'll write the answer down in a minute. So you can see what I've done here is I did 58, this test result this person got, minus the mean, and I found that this person is 20.6 points below the mean, so negative 20.6. This person here was higher than the mean. 84 minus 78.6 is 5.4. Now what we're going to do is we're going to do that for every single number in here, and we're going to do that in Excel in a moment to speed things up. And then we're going to actually try to think of a measure of how spread out they are from the mean. But the problem is some of them are positive numbers and some of them are negative numbers. So if we just find the mean of this column, the minus 20.6, 5.4. The negatives will cancel out somewhat with the positives, and we won't get a good measurement. So what we actually have to do is square the numbers. When you square a number, it becomes non-negative, i.e. 0 or above. So all of the numbers in this column will be squared and all be positive. And so that's what we're going to do. And then we're going to take the mean of this column of numbers to get a measurement of how spread the data is from the mean. Okay, let's do that in Excel because that's a lot quicker. So here I have a column for x minus the mean. So I'm going to click equals, click on my x number, which is the mark they got, minus the 78.6, which is the mean, and hit enter. And that's brilliant. Then I want to square that number. So click on that cell, write equals, click on that cell and do to the power of 2. You can see I've got that in there. So that's shift 6, 2 squares the number to make it positive, and I get the same number I got in the OneNote, 424.36. Now, Excel being a beautiful program, I'm just going to highlight those two cells, change my white cross to a black cross, left click, and copy all the way down. And you can see there I get all of these squared numbers. So now I want to work out the actual sum of all of this column here. So let's do that. So I want to take the sum of all of this column here. So I'm going to sum this column. So equals SUM for sum, and I'm going to sum all of the squares of the distances from the mean. So that's what that's representing. So that's the sum of all the squared differences from the mean. Let me show you what that looks like in a formula. So this column here represented the distance from the mean, the score in the test x minus the mean, which was minus 20.6. This is the number squared, x minus the mean all squared. And when I added all of this column together, I got the sum, which is capital sigma, of all the scores, the test scores minus the mean squared. And that's the number that we're interested in this case, and Excel worked it out for us, which would be the sum of this whole column. And you can see that the sum of the distance from the mean all squared was 1923.6, which we can see in the one note here. Now the variance formula is given by that for a population. The variance of a population is the sum of all of the distances from the mean squared divided by the number you've got. So in this case we have 15, so all we have to do to find the variance of the population, which is a measure of spread, is do the 1923.6 divided by 15, and we'll just work that out. And I get a variance of 128.24. Let's check that on Excel and show how to do it using an Excel formula. So I have the sum of all of the distances from the mean squared here, 1923.6, and basically I want to divide that by 15. So I equals that cell divided by 15 equals, and we should get the same answer. There we go, 128.24. Now the standard deviation of a population is actually very straightforward. It's just the square root of that. So all I have to do is equal SQRT. There's the square root function, square root that number, hit enter, and there's my standard deviation. Now the reason we square root is, imagine these were in fact heights of bonsai trees in centimetres. So if these were heights, when you squared the distances here, you get centimetres squared. So it makes sense to take the square root to preserve the units back to centimetres. So that's one of the reasons statisticians like to take the square root. So standard deviation and variance are measuring the same thing, the distance of the mean from the mean squared. Okay, now let me show you how to do that in a formula in Excel straight away. So I'm now going to show you how to get that same number without having to do all of this in Excel. So make sure we can see our formula bar here. So I'm going to hit equals, and I'm going to write ST for standard deviation, and you want to choose this little fella here, standard deviation of a population. It tells you what it is. Calculates the standard deviation based on the entire population. Don't choose standardized, don't choose sample. I'll teach you how to do sample in a minute. So click on that, and then all you have to do is highlight the original data, close the bracket, hit enter, and Bob's your uncle. I would have been really upset if it came out with a different answer. You'd be thinking, what's my teacher doing? And you can see we've saved all of the steps. But it was nice to do it on Excel to show you how standard deviation works. You will be able to you will be required to be able to do this by hand and also using the Excel. So now I want to tell you about standard deviation of a sample, which is slightly different. So to work out this variance and standard deviation of a sample, it's almost identical. We're still going to work out the mean. It's a pretty horrible number now. It's 78.8888 recurring, so I'm going to cell reference that. So to work out x minus the mean equals 86 there, click on that badger, minus, and I'm actually going to click on this cell now because it's not a nice number, but I don't want this number ever to change. So $C, $34 means always go to column C, always go to 34, do not pass go, do not collect $200. That bit was a joke for you Monopoly players. So that's how to cell reference when it's a horrible number. Hit enter, and it's the same idea though. That's the number, that's the difference from 86 minus the 78.88 recurring. I want to square that badger, so equals, hit on that cell, shift 6, 2, you can see I've entered it there, equals E25 squared, hit enter, copy all these numbers, highlight both cells, make a black cross, left click, drag down, Bob's your uncle. So same as before, I've got all negative and positives here, I don't want to find the mean of those. I don't want to sum those because they'll cancel each other out, but I do want to sum the positive ones here. So equals sum. Let's sum these little squirrels. So we've got these little squirrels summed, and we get 788.88 recurring. Now here's the twist. Unfortunately, what we actually want to do is take this sample of test scores, which is a sample from Class A. I took 9 students from Class A randomly, so it's the same data as here, but I took a random sample of them. And we want to use this standard deviation to estimate the actual standard deviation. So to do that in an unbiased way, you have to divide by n minus 1, not n. So take the sum, 788.888 recurring, and divide by, whoopsie-daisy, divide by not by 9, but by 8 when it's a sample. That's the only difference. Divide by n minus 1. Click on enter. Bob's your uncle. Same as before. Take the square root of that equals SQRT, square root of that number, and we get the sample standard deviation 9.93, which is an estimate for the population standard deviation, which was 11.34. So now, how to do that on Excel so you don't have to do all this. So equals ST, and this time choose the STDEVS, which is, if I just move this across here, you can see, move that up there, sorry, estimates the standard deviation based on a sample. So that's the one we want. So if you're collecting your own data, then you will, and that's a sample data, which I know lots of people do in projects, then what you need to do is the sample standard deviation, not the population. So you have to decide, is it a sample or is it a population? And there you can see I've got the same answer again, 9.9303. Bob's your uncle. I'd be worried if it was different. So that's how to work out standard deviation and variance for samples and populations, showing all your working or doing it really quickly in Excel. Thank you very much for watching. Please ask any questions. If you liked this, subscribe to my channel and give me a thumbs up. Have a great day, everyone.